This webcast discusses how to complete Experiment 3 in the Gravitational Force Lab. Now, in Experiment 3, we're going to hold the masses of both Object 1 and Object 2 constant, and the independent variable, the thing that we will change, will be the distance between the centers of those two masses. And so I'm going to go to the simulation tool, and I'm going to choose values of mass 1 and mass 2. Please do not use the same values that I'm showing here. You choose your own values and have them be different from the people around you. Okay, but I'm choosing values of 250 kilograms for mass 1 and 740 kilograms for mass 2. Okay, and you should record your values, which will be different than mine. I am going to go and put my data directly into Microsoft Excel. So I'm going back to my Microsoft Excel sheet. And gosh, I guess I see that I need to save this. So I'm going to do a file, save as. Remember that Excel does not automatically save for you, and so you will need to save it so that you don't lose your good work. Okay, so I'm going to put this under Unit 7, under the lab for gravitational force, and I'm going to call this Okay, but I'm going to create a new sheet. So I'm going to click this plus sign down at the bottom of the worksheet, and I'm going to make a new sheet for Experiment 3. I want to record my constants because they are so important to being able to analyze this data correctly at the end. So mass 1 I'm holding at 250 kilograms, and mass 2 I'm holding at 740 kilograms. Yours should be different than mine. Okay, and then I'm going to make a table, independent variable on the left, dependent variable on the right. Now my independent variable is the distance between the centers of the masses. It's going to be measured in meters. My dependent variable is the gravitational force, which is measured in newtons. And I obviously need to wrap text here so that I can see my, the full words here of my, there we go. Okay, so I'm going to put my data in this table as I get it. So the first distance that I should use is 1.2 meters. And so be careful as you choose this distance. I need to make sure that for the blue mass, mass 1, the blue dashed line is aligned with the 0 on the ruler. Okay? And then I need to make sure that the red dashed line, which is showing the position of mass 2, is set at 1.2. Don't push them as close together as you can get them, because that's not quite on 1.2. We have to be very careful to get accurate distances. Okay, so now I have chosen that distance in the table, and I can see what the force is. And so let's see, I'm going to have to move the decimal place 1, 2, 3, 4, 5, 6 places to the right. So I have 8.574339. Let's see, I'm going to put this into Excel. 8.574339 e to the negative 7th. Did I say that right? No, 6. E to the negative 6. Okay, so that was for a distance of 1.2 meters. And now I'm going to keep, the only thing I'm going to go change is the distance between them. Now the distance should be 2 meters. So I'm going to go here, I'm going to pull the red mass to the right to a point to where it is at 2 meters away from the blue mass, and I'm going to record this new data. So now I still have an e to the negative 6, but it's going to be 3.086762. e negative 6, okay? And that's for a distance of 2 meters. Okay. After you have recorded all of the values for experiment 3, we want to get a scatter plot to see what type of relationship gravitational force has to the distance between the centers of the masses. So highlight those numbers and insert a scatter chart. Oh, look at this. So this is definitely a curved graph. So I'm going to, let's get some good labels on it. This is gravitational force versus the distance between the masses, and this is for mass 1 equals 250 kilograms and mass 2 equals, for me, 740 kilograms. So since the constants are so important in this experiment, I'm just putting those in my graphs as well. I definitely don't want to lose them. Okay, the independent variable is distance between the centers of the masses, and that was measured in meters. The dependent variable is the gravitational force, measured in newtons. Okay, so a beautiful graph. It's curved, and it looks like an inverse function because as the distance is increasing, the gravitational force is decreasing. They are moving in opposite directions. As one gets big, the other gets small. Okay, and so this would be, you know, our figure 5. Okay, because this graph is curved and resembles actually the inverse square function, where y would be some constant times 1 over x squared, it equals some constant times 1 over x squared, we're going to create a formula in Excel to calculate the inverse square of the distance. And we're doing this to try to linearize the graph so that we'll be able to write a physics equation for it. Okay, so going back to Excel, and I'm going to just copy the original table of data. Just do a Control-C, and I'm going to move it over to the right-hand side of the graph. And now I've copied the gravitational force. I'm going to leave the force the same, but I'm going to change the independent variable column. Instead of being the distance between the centers of the masses, now I want the inverse square of the distance between the centers of the masses. The units are going to be 1 divided by meters squared, right? Because I'm taking the inverse and I'm squaring it. I'm going to just delete these numbers because I do not want to use that distance anymore. Instead, I want to use the inverse square of the distance. And so I'm going to create a formula to calculate the inverse squared. And when you want Excel to calculate something, you begin with an equal sign. Okay? Then I'm going to slide my cursor over to the left, and I'm going to click. Oh, wait a minute. Let me not do that for a second. I want the inverse squared, so I'm going to say equal 1 divided by, okay, because I'm taking the inverse, and then I'm going to click in the cell that has the distance between the centers, so it has now captured that 1 divided by, it's going to go to cell A9 to find that distance, and I want to square that distance. So I'm going to use the Shift-6 key to get the little upward caret, and I'm going to type the number 2 because I'm raising that distance to the power of 2. Okay, so this is 1 divided by 1.2 squared. I'm going to copy this formula down to the bottom of this column. One way to do that is to bring your cursor into the lower right-hand corner of that cell that has the formula and then just double click. Okay. Now that I have the inverse square of the distance, I'm going to make a graph and see if I was able to linearize it. So I'm going to highlight the numbers here of gravitational force versus the inverse square of distance. I'm going to insert a scatter plot. And look at this. It is beautifully linear, and so we're going to be able to write a physics equation for this one. But first let's do a nice label of this. So this is gravitational force versus the inverse square of the distance between the masses. And so now on the x-axis I have the inverse square of the distance, and that's in units of 1 divided by meters squared. And then I still have on the y-axis the gravitational force, which is measured in newtons. Okay. So since we want to write a physics equation for this graph, which is now linear, we're going to need to do linear regression to find the slope. And so I'm going to go up to the Data tab, and over on the right hand side to Data Analysis, I'll go to Regression, and let's see, I'm going to delete what was there before. Okay, so I want to put the cells that have the data on the y-axis, and in this new graph the y-axis has the gravitational force. So I will click here to go back to the sheet, and I'm going to highlight the cells that have the gravitational force data. Then I need to put in the data that has the information on the x-axis, and so I'll click here to go back to the sheet, and I'm going to click the cells that have the inverse square of the distance. Okay, and then before I click OK, I want to make sure that I have put checkboxes for the residual plots and the line fit plots, and then say OK. Okay, I'm going to go to the Home tab and choose Auto Fit the column width so that I can see all of the data here. Let me just separate these graphs. And I have a good linear regression. I have a very decent R-squared, and when I look at the line fit plot, the predicted values are overlaying the actual data, so that's a good sign. And so I want this x variable 1 number, that is the slope of this graph. By the way, we are creating multiple linear regression outputs, and so up here I'm just going to change this summary output. I'm going to say for experiment 3, and that way when I snip these and put them in my lab report, it'll be clear that this one was for experiment 3. Okay, but I want to write down this slope, 1.235 times 10 to the negative 5th. Let's see here. If I look at my graph again, so I'm going to go back to the sheet that has my graph, the units of this slope should be newtons divided by 1 over meter squared, right? I had newtons on the y-axis and 1 over meter squared on the x-axis. And so now we could write a physics equation. Now my independent variable is the inverse square of the distance, and I'm going to call that 1 over r squared. I'm using r as the distance. My dependent variable is still the gravitational force. And so I'll just use F with a G subscript to represent that. Okay, so now we have a graph where the gravitational force equals my slope, times 1 over r squared, the inverse square of the distance r. Okay. Okay, that is experiment 3.